Hello everyone, welcome to the video presentation on machine drawing 15ME 34D for third semester diploma mechanical engineering from the Department of Collegiate and Technical Education, Government of Karnataka. Myself Muhammad Imran, lecturer in Department of Mechanical Engineering, Government Polytechnic, Karwar. So in the earlier videos we have studied how to draw square headed bolts, hexagonal headed bolts with both the view across corner and flat, and after that we have studied three views of the square headed bolts with a view across corner. Now today we will study how to draw the three views of the square headed bolts with a view across flat. Earlier we have studied corner, today we will study about view across flat. So I told you the difference between view across flat and corner in the beginning video. So to begin with the data given is here, view across flat. The data remains same, only the view across corner will be shifted to flat. So length of the bolt is 120 mm and threaded length is 60 mm and the M20 nominal dia. So with that diameter you have to above all the other dimension. Width across the flat we get 1.5D plus 3 mm, we get 38 mm since our diameter is 20. If it varies, also this dimension varies. What is the nominal diameter is given in the examination, that diameter you have to take for the further calculation. So we have given 20 mm dia, so I have calculated these parameters according to that diameter. So thickness of the bolt head 0.8D 16 mm and thickness of the nut 0.9D, that is 0.9 times the 20 mm 18 mm will get. Core diameter of the thread 0.9D 18 mm. Conical chamfer at the bolt end 0.1D into 45, 0.1 into 25, 45 degree. Now begin with the drawing. Draw the axis line. Okay. Draw the axis line. Since our nominal diameter is 20, so take 10 mm above, 10 mm below. Length of the bolt is 120 mm. So draw 120 mm here. The end of the bolt. Since we are weaving view across the flat, so width of the flat we got 1.5D plus 3 mm. So either you can draw it by drawing side view and projecting that, or either directly you draw the width of the nut head, because we calculated the dimension, we got 30 mm, 38 mm. So 19 mm above, 19 mm below. You can draw either side view. First you draw the side view and you can project, or since you know the dimension, you can draw directly. But in the case of view across corner, we cannot draw the front view bolt head width directly, because we know we don't have any particular formula for that. First you have to draw the side view, then you have to after getting the corner, then you have to project that. Since we are this is view across the flat, we directly got the dimensions, so we can draw here. Thickness of the nut we got as 0.8 D, that is 16 mm. Mm. Similarly, the thread length is 60 mm. 60 mm. Measure 60 mm here. Draw a line. Now draw the nut position anywhere in the 60 mm. I have explained this, whether you can draw the nut position start anywhere from here to here, unless otherwise it is mentioned in the problem. So project this and project this. Start anywhere here, nut position. I'll draw here, and thickness of the nut is 0.9 times the D, that is 18 mm. Okay, got the layout for bolt and nut. So erase these projections, not required. Now you draw the core diameter, that is 18 mm, 0.9 times D, so 1 mm below, 1 mm above. Chamfer length is 2 into 45 degree, so measure 2 mm here. 0.1 D into 45, 0.1 times the D is 20, is 2 mm. So 2 mm you measure here. Two mm. Draw a line, and then 45 degree line. Forty-five. Remaining portion you erase it. Yes. Now get two faces. You get only one faces when you view across the flat. Since square is like this, square is bolt is like this with a square head. So if you view from corner like this is the corner view. From the front view you can see two faces, this face and this face. But since it is view across flat like this, you have to see view across flat. So in the front view you can see only one face, this face, only one face, this face. In top view also you can see this only one face. View across the corner means like this. So in the side view, front view, you can see two faces. But here it is view across flat like this, view across, this is the flat. So in the front view only you can see the one face, and also in the top view only you can see is one face. Chamfer for this is very simple, unless it is complicated in the earlier bolts. What you have to do for drawing chamfer is 2 times the diameter. Chamfer radius equals to 2 times the diameter for both nut and bolt. 2 times the diameter is 40 mm. From this edge you have to measure 2 times the 40 mm, that is 40 mm here. Measure 40 mm here, and also from here 40. This is one center and this is one center. Then this as a center, and radius equals to this one. See, this is the center. The center is what? This is 2 times the diameter. From this center, draw a arc. You can see only one face, so you get only one radius. There is no chamfer angle for one face, so you have to darken all this is visible faces, visible edges. This one darken this. Similarly here, draw the 2 times the diameter, 40 mm radius, draw the arc. Now darken this. This inside face is not visible, so erase this. This radius is 2 times the diameter. 2d equals to 40 millimeter. The diameter varies, this radius also varies, dimension of this radius. This also 40 mm. This is the width across the, this is the width of the bolt head, width of the nut head. This diameter is, this thickness is 0.8 times the diameter, that is we got 16 mm. That is 0.9 times the diameter, this is 18 mm. And this is your T. Diameter D, this is 20 millimeter. This arc is also same. This radius is also 40 millimeter. This completes the front view of the square headed bolts with a view across flat. Now you will draw the side view of this. For drawing side view, match the center line. Whenever a drafter get offset to draw the angle lines, you have to match with your axis lines so that you will get straight projections. That you have to remain very important point, these things. Otherwise, that if it varies means everything, the projection will varies. That you have to keep it in mind. Draw the projection. Since width of the flat means both side will get 1.5D plus 1.53 mm, so that is 38 mm. So 19 mm from here, 1938 here. This is the circle, square. Here the dimension, both side is 1.5D plus 3 mm. 1.5D plus 3 mm, that is 38. This is also 1.5 times diameter plus 3 mm, that is 38 millimeter. Now the chamfer circle will be like this. It is also 1.5D plus 3 mm. Draw a circle of radius 1.5 mm, of diameter 1.5D plus 3 mm, that is 38 mm, and radius will be 90 mm, or you just measure this radius because it is a 38 mm. So here it will get tangent to all the sides of the square. Now draw the nominal diameter circle. It is very difficult to draw in a protractor. Use divider, use pro circle, 20 mm. So draw the circle, complete the core. Now I have to draw the core diameter of 19 mm, that is 3/4 circle, indicates the threading. Yeah, this completes the front view and side view of the hexagonal headed bolts. Only where we left with the top view. Top is very similar to the front view. There is no any variations, but at a procedure we need to draw that. Draw a 45-degree line. To get the projections. Project this, project this. Project the center. Project this. and project this end of the bolt. Now better to draw the radius. Radius will remain same, 2 times the diameter, 40 mm, and center also I am projecting because it is same. This is center, that is 2 times the diameter, 40 mm radius. If the diameter is 30, that will be 60 mm. Varies according to the nominal dia. See here. Here. Yes. Now darken this. Everything is visible here. One, darken this. Two mm here for chamfer line. -45 degree here. Remaining portion you have to erase. Also draw the core diameter here. This you have to darken. So this completes the top view of the 3 views of the hexagonal headed bolt, square headed bolts. Length of the rod, length of the so giving dimension, this dimension is 1.1 D into 45 degree, that is 2 mm into 45 degree. There is no chamfer line here, and this dimension is given, and this dimension is 1.5 D times 38 mm, radius is 20. This length of the thread is, this length of the thread is given as it is mentioned in the problem. This will be 120 mm. If the length of the thread is not given, then you have one formula that will be not the length. Length of the thread is always mentioned. I am talking about this thread length. thread length is also given. This thread length is 60 mm. If this thread length is not given, then we have one formula that is 2d plus 6 mm. 2d plus 6 mm. That means in this case, if we assume that the length of the thread is not given, then you have to use this formula 2d plus I'll write here visible, yeah, 2d plus 6 mm if the length of the thread is not given. So 2 times the diameter is 20 plus 6 mm. This formula is for length is less than 150 millimeter. If the length is less than 150 millimeter, then you have to use this formula. In our case, the length is 120 mm. I am just talking normally. The thing is that the length of the thread is given in this problem. If the length of the thread is not given in the problem, then you have to use this formula 2d plus 6 mm for the length less than 150 mm. So that will be 40 plus 6, 46 millimeter. If it is not given, then you have to use 46 millimeter, but it is given. Similarly, if the length is greater than 150 millimeter, then you have to use the formula 2d plus 2d plus 12 mm. 2d plus 12 mm. That will become 2 times the 20 plus 12 mm, 52 mm. If the length is greater than 150. In our case, the length is 120. That means you have to use 46 mm if the thread length is not given. So this about the drawing of 3 views of the square headed bolts with a view across flat. So in the next class, we will study about the cylindrical bolts. So up to that, thank you one and all. Thank you for your cooperation. Myself, Mohammad Imran, lecturer, Department of Mechanical Engineering, Government Polytechnic, Karwar. Thank you one and all for your cooperation. We'll meet you in the next video. Thank you.